In question number 5, the polynomial is denoted by f of x, where p, q, and a are constants. When f of x is divided by x plus 2a, the remainder is minus 22a cube. When it's divided by 3x minus a, the remainder is minus a cube. We have to find the values of p and q. Now, when it is divided by x plus 2a, that means we will write x is equals to minus 2a and substitute it into the function. So in place of x, we will write minus 2a. So it will become 3 into minus 2a whole cube plus p into a into x again will be minus 2a whole squared plus 7a squared into minus 2a plus qa cube, and this is equals to minus 22a cube. Simplifying this, so this will become minus 8a cube multiplied by 3. That will become 24a cube with a negative sign. This will become plus 4a square. So this will become plus 4pa cube. This will become minus 14a cube plus qa cube is equals to minus 22a cube. Now we can see that a cube is common in all of the terms. We can just take a cube common out and simplify this as minus 24 plus 4p minus 14 plus q equals to minus 22. And we can simplify this as well to make our first equation, and that would be equals to, so 4p plus q, we can leave it on one side. So 4p plus q will be equals to minus 22 plus 14 and plus 24. So 4p plus q, so minus 22 plus 14 is minus 8, minus 8 plus 24 would be plus 16. So this will be our first equation. Now we are also given that when it's divided by 3x minus a, so 3x minus a, will put it as 0. So x would be equals to a upon 3. Now in the same function, we'll substitute x is equals to a upon 3. So this will become 3 into a upon 3 whole cube plus p a into a upon 3 whole squared plus 7a squared into a upon 3 plus qa cube, and the result is equals to minus a cube. Simplifying this, we'll get 3 into a cube upon 27 plus pa cube upon 9 plus 7a cube upon 3 plus qa cube equals to minus a cube. Now, just for clarity, we had AQ over here as well, so it cancelled out in on both the sides. So similarly over here, if we take a cube common out, we can first simplify this as well. So this will become upon 9. So if we take a cube common out over here, we'll get 1 upon 9 plus p upon 9 plus 7 upon 3 plus q, and that would be equals to, so if we take, if you have minus a cube over here, it will cancel out and it will be equals to minus 1. So we'll get 1 upon 9 plus p upon 9 plus 7 upon 3 plus q equals to minus 1. We can simply take the LCM as 9 over here. So this will become 1 plus p plus, so this will multiply by 3. So this will become 7 times c 21. This will multiply by 9. This will become 9q equals to minus 1. Simplifying, we'll get p plus 9q is equals to minus 9. And then this will become minus 21 and minus 1. So finally, our second equation would be p plus 9q equals to minus 31. Now we can solve these two equations simultaneously. The first equation was 4p plus q. 4p plus q equals to positive 16. We can simply multiply this equation by 4 and this by 1. We can multiply by minus 4. So this will become minus 4p plus 36q equals to 31 times 4 would be minus 124. So 4p and minus 4p will cancel out. This will become minus. So this, when you multiply it by minus, this would have become a minus. And this would become a plus over here. So we'll get Q minus 36, Q is minus 35, Q is equals to 140. So 140 divided by minus 35 would be equals to minus 4. Now, once we have the value of Q, we can easily find the value of P by substituting it into any of the equations. We have the first equation as 4P plus Q equals to 16. Q is minus 4, so 4P minus 4 equals to 16. 4P equals to 20. The value of P would be equals to 5. So the values of P, we can finally write it as P equals to 5 and Q equals to minus 4.